Alright, so today we are talking about 5.3c, manipulating quadratic equations. First thing is we're going to change back and forth between standard form and vertex form. If you remember, standard form is y equals ax squared plus bx plus c. And vertex form is y equals a times x minus h squared plus k. And remember, there's different things about these. Remember, for here it was easy to do the y-intercept because it's just 0c. Not so easy here, but here it's easy to get the vertex because it's just given as hk. Remember, it's opposite same. So in changing from vertex form into standard form, this is kind of the easy way. There's 3 steps. The first step is to simply FOIL. And if you remember, FOIL means first, outside, inside, last. And so I take my equation, y equals 2, and I need to FOIL this. What does that mean? That means x plus 1 times x plus 1 minus 4. And now again, I have to FOIL this. This is always the first step because I need to multiply before I add or subtract. Now, could I distribute the 2 first? Yes, but it's a lot easier if we just FOIL first. 2 times x squared plus 1x plus 1x plus 1. And then minus the 4. Now, that leads us to the second step, which is distribute. So I'm going to take whatever this is and do that. But you know what? Before I do that, I should probably combine like terms. Okay. And so if I combine my like terms, what I mean is the outside and the inside term. So I got 2x squared plus 2x plus 1. Don't forget about that minus 4 out there. Now when I distribute, am I going to distribute that 4 as well? No, because it's not in the parentheses. So I distribute the 2x squared plus 4x plus 2. And of course my third step is combine like terms. Okay, sorry I'm writing kind of funny. This pole is in my way. Anyways, so I just literally look at the 2 things I can combine here, and I get 2x squared plus 4x minus 2. Is that easy? Okay. Second one, same kind of thing. It's a matter of fact, it's the exact same problem. It's just with a fraction, and I know you're all thinking gross fraction. It's not that bad. Just take half of a number. It's not that bad. So again, first step, I'm going to rewrite this as x minus 2, x minus 2. Everything else is coming with it, so I'm just going to write y equals negative 1/2 x squared minus 2x plus 4 plus 3 in the end. Combine these 2 like terms. Remember, they don't eliminate each other. They're negative 2 and a negative 2 is a negative 4. So I get negative 1/2 times x squared minus 4x plus 4. And then I distribute the half. So the half gets distributed here. Negative 1/2 x squared. Half of 4 is 2. Negative times negative makes it positive. Negative times positive makes it negative 2. And then again, the last step is to just combine those. So we get y equals negative 1/2 x squared plus 2x plus 1. It's that easy. Okay? The bell's going to ring here in a minute, so bear with me. Let's go down to the bottom. Okay? For the bottom ones, it's a little bit harder. I think the easy way is to do this in 2 steps. First step, identify A, B, and C, and plug in A. What do I mean by that? I mean A is 2, B is 4, and C is 7. Okay? So I've got my formula. It's going to look like this. The A is the same in both forms. Notice that up above. When it was 2 here, it was 2 here. When it was negative half here, it was negative half here. A never changes in either form. So I've got this y equals 2 times x minus something squared, and I know I got to fill in something on the outside too. Well, what do I got to do to find this? This is our vertex x and y value. We'll define the x, so that's part 2. Find vertex. The vertex is hk. Well, remember, to find the h value, we need to do the opposite of b over 2a. Okay, so I'm going to take my x value, I'm going to take the opposite of b, divided by 2 times a. I get negative 4 over 4, which is negative 1. So guess what? That goes here. We'll fix it later. You should know that minus a negative would zip zap. But let's keep going here. How do I find the other one? Remember, we plug it in to original x. Well, what does that mean? That means these two spots right here. So I'm going to have y equals 2 times negative 1 squared plus 4 times negative 1 plus 7. This is 1 times 2 plus negative 4 plus 7, 2 minus 4 plus 7, negative 2 plus 7. Lots of work, lots of steps here, but a lot of this you'll probably be able to do in your head. And I get 5, and guess what? That's that. Plus 5 because it's positive. If it was negative, we just write minus 5 there. Let's rewrite this whole thing now as y equals 2 times x plus 1 squared plus 5. And that's it. That's our answer. Okay. Let's do this last one here. So same kind of thing. A is negative 3, B is 12, C is 5. Find our vertex, which is the opposite of B over 2A, which is negative 12 over 2 times negative 3. Negative 12 over negative 6, of course, is 2. Oh, I forgot to even start the problem. Again, it's negative 3, x minus something squared. Well, there it is, right there, the 2. I'm going to go plug 2 back in. I get negative 3 times 2 squared plus 12 times 2 plus 5. This becomes 4, of course, because 2 squared is 4, and times negative 3 gives me negative 12, plus 24 plus 5, 12 plus 5 is 17. And again, that's my y value of my vertex. There's my answer. Done. Your homework is to do 1, 2, scratch out 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, and scratch out the graphs because we already did something with that. There you go.